We hear about artificial intelligence literally constantly. It's in the news, on our phones, it's pretty much everywhere. But so often it's talked about like it's some sort of digital magic, right? Well, today we are going to completely strip away that magic and look at the actual architecture of intelligence. We're breaking down the absolute fundamentals of deep learning, completely demystifying how it works, and showing you exactly what is happening under the hood in this explainer. I mean, think about it. How exactly does Netflix know exactly what movie you want to watch on a Friday night? How does your smartphone instantly recognize your voice and translate your speech right into text? Or how on earth do self-driving cars detect pedestrians and stop signs in real time? Well, the invisible engine powering all of these everyday applications is just one thing: deep learning. And by the end of our time together today, you're going to understand exactly how it pulls this off. Here is our roadmap for today. First, the magic of deep learning. Second, inside the neural network. Third, real-world image classification. Fourth, the math behind the model. And finally, number 5, deep learning myths and summary. Okay, let's dive right into section 1, the magic of deep learning. So deep learning isn't just its own completely separate thing floating out there. It's actually a specific subset of machine learning. And what makes it incredibly unique is that it uses these things called neural networks, which are literally inspired by the biological structure of your own brain. But the absolutely crucial part here is that it learns patterns automatically, without us giving it explicit rules. You see, in traditional computer programming, a human has to sit down and meticulously write rigid, step-by-step rules for the computer to follow. Deep learning flips that entire concept upside down. Instead of writing the rules, we just feed the model a ton of data, and it literally teaches itself based on the information we give it. Pretty wild, right? Moving on to section 2, inside the neural network. Okay, so how does it actually teach itself? Well, the continuous loop that makes deep learning possible happens in 5 very distinct steps. First up, we input the data, say an image file. Second, that data passes through multiple interconnected layers inside the network. Third, at each stop along the way, every individual artificial neuron applies a really small mathematical calculation to that data. Fourth, the network spits out a prediction and then calculates its errors. Essentially, it checks its work to see how wrong it was. And finally, step 5, it adjusts its internal settings, which we call weights, to be just a little bit more accurate for the next time around. This continuous, relentless loop of calculating, checking for errors, and adjusting, that is exactly what we call training. Now, the deep and deep learning actually refers to the fact that there are many, many layers in these neural networks. But let me ask you this. Why do you think more layers actually help in better learning? Why wouldn't we just use one giant massive layer and call it a day? Well, it's because each subsequent layer learns more complex features. A shallow network can really only understand super simple things. But by stacking layers on top of each other, the network builds a way deeper, richer understanding of the data as it moves through the entire system. Basically, each layer takes what the previous layer figured out and combines it into a higher level concept. It's like building a giant puzzle piece by piece. That brings us to section 3, real-world image classification. Let's actually see this progression in action because it's super cool. We're going to ask our neural network to classify an image and decide, is this a cat or is this a dog? So we start with our input, just raw image pixels. The computer obviously doesn't see a cute furry animal, it just sees a massive grid of numbers representing colors. That data hits layer 1. Now, layer 1 has no idea what a cat is. It's only responsible for detecting really simple edges and lines. Then it passes those edges along to layer 2, which combines those lines to detect basic shapes, like circles or triangles. Next, layer 2 passes those shapes to layer 3, which combines them to detect far more complex features. Now, the network is actually recognizing an ear, a snout, or an eye. Finally, based on all of those complex features, it reaches the output layer and makes its ultimate prediction, cat or dog. Deep learning automatically learns to build these features layer by layer, totally on its own, no human handholding required. All right, section 4, the math behind the model. You might think the math behind this is insanely complicated, but the basic operation happening inside a single individual neuron is incredibly simple. You have an input number coming in, let's say it's a 2, and the neuron has a specific weight attached to it. Let's say that's a 3. The formula the neuron uses is literally just multiplying the input by the weight. That's it. And the answer, of course, is 6. 2 times 3 equals 6. That is a basic neuron operation. It's just simple multiplication. However, what makes deep learning such a real game changer is scale.
In a real deep learning model, you aren't just doing this once. You're taking this incredibly simple operation and applying it across thousands and thousands of neurons. In fact, modern models perform trillions of these exact, simple multiplications every single time you ask them a question. So the math is simple, but the massive, mind-boggling scale is what actually creates the intelligence.
Which leads us to our final section, number 5, deep learning myths and summary. You know, a really common mistake people make is believing that deep learning is just magic, that it's some sentient, completely unexplainable force. But as we've clearly seen today, that is absolutely false. The reality is that deep learning simply requires two very tangible things: large data to learn those patterns from, and high computation to actually perform those millions of basic math equations. So it's not magic at all. It's just math, data, and immense processing power.
Let's quickly summarize our core takeaways here. Deep learning is an advanced subset of machine learning. It utilizes neural networks that are directly inspired by the architecture of the human brain. Instead of relying on explicit human programming, it learns patterns automatically by passing data through progressively complex layers. And bringing us full circle, this exact process is what powers the image and speech recognition in our phones and the object detection in our self-driving cars.
To wrap up this explainer, I want to leave you with a direct challenge. Question 1, what is the role of hidden layers? And question 2, what is the exact difference between machine learning and deep learning? If you can answer these two questions right now, you've successfully grasped the architecture of modern artificial intelligence. So I'll leave you with this final thought. Now that you know the invisible engine running the technology all around you, where do you think this automatic pattern recognition is going to show up next in your daily life? Thanks for joining me today. Keep questioning and keep learning.